Geotrig, lesson 13. Today we're going to talk about things, lines, so secants, chords, things that are going to intersect. So the first thing we're going to talk about today are intersecting secants. So we got to go back to lesson 11, so 2 lessons ago, and put in there, what's a secant? Maybe we should just write this down again. What's a secant? It's different than a chord.
A line that intersects a circle at 2 points.
Okay, it's a line that intersects a circle at 2 points, and I just realized I wrote that in the wrong spot, but we will fix that. So just move that, guys. Line intersects a circle at 2 points. So obviously, if you look at the little diagram right there, we have how many secants? 2 of them. Now, today is not difficult mathematical-wise, but there are 1, 2, 3, 4 formulas that you guys will have to know. The cool thing about it is 2 of them only differ by adding or subtracting. And the other one, there's a little bit different thinking on that one. So these ones, for this particular case, where do the 2 lines cross? In the middle somewhere. Can we guarantee that that's in the middle or the center of the circle? No. It's important to know this. Does not have to be in the center. Center, I think, would be somewhere about here, yeah? So the rule says that if 2 secants intersect inside the circle, notice it doesn't say inside the circle at the center. It just says inside. The measures of the angles, the angle, or angles, technically, because there's 2 of them, 4 of them, really. The angles formed is equal to half of the sum of the intercepting arcs. So, I've got arc 1 and arc 2. If I add them together and divide by 2, I get x. How come I not get 2x? Because there's an x here and there's an x over there. Why is that? They're the same thing, right? They're vertical angles. That's why I have an x over here, and an x over here. Is because they are the same thing. And so that formula is the one we use. In other words, just take the average of the length, right? Length in degrees, because it's the arc length, to find your number. This gives us x. X is in degrees. Our angles are in degrees. Our arc lengths are in degrees. Okay? So, still working on that whole idea that circles have arcs, and there's a connection between certain arcs and lines and secants and angles. So, today I'm going to give you all of the notes first, and then we're going to go through all the examples. You guys good? Yeah. Next page. Now we have intersecting secants and tangents, and their variations. You can have, again, 2 secants intersect. Where do these secants intersect? Here, where do they intersect? Are they inside? No, they're outside. We could have a tangent and a secant, but they also will meet outside. And we could have 2 tangents. The 2 tangents meet on the outside. Notice x is always the angle formed on the outside. And again, because those are vertical angles, both of these inside here are x. Now, we were inside last time. Last time we were inside, we added. If we're going to be outside, we will subtract. Boom. And look at that. Formula magically appears. Now, we can use arc 2 minus arc 1. On the last problem, we added. It didn't really matter because you can add our numbers in any order. Which one you call arc 1 and arc 2? Which one happens to be arc 2 on every single one of these problems? The one on the far right. I could take this diagram and flip it around. So maybe the far right is not the best idea to call it. How about the longest or biggest arc? Can you guys see that this arc here, arc 2, is bigger than arc 1? Mm-hmm. Arc 2 is definitely bigger than arc 1, and so forth. So maybe I don't want to remember this one as always arc 2 minus arc 1. Maybe I want to use it as x equals big arc minus little arc over 2. Just some way for helping us remember what they are. Now, what's going to happen is that you're going to be given problems with numbers at the arc 1, arc 2, and x, and solve for one of the unknowns. You're going to have to write down a formula so you can fill it in. Sophomores, juniors, you should know quadratic formula by heart. You should know slope-intercept form by heart. Point-slope form. The slope formula by heart. You should not need to look this stuff up. These I'm also going to require you to know. They're not that overly complicated. Inside, add. Outside, subtract. Maybe compare it to inside it's a positive temperature. Outside, right now this time of year, it can start to get to be a negative temperature. Maybe not this far yet this year, but kind of like right now, feels like it's cold outside. So it's cold, subtracted, temperature, minus. I know, some idea. Okay, does everybody have those? There's more. Just wait for one low, low price. We get when we have chords and secants and tangents. These are the last three before we get into examples. The top one, we've seen this one already. So you shouldn't have to write that. But when we have chords that are crisscrossing, you just take their individual parts, multiply them, and they equal the individual parts multiplied on another chord. Yes?
We
also have secants and tangent segments. Hey, look at that. I got two secants, right, from a common point here, going through the circle. There's also a really cool, nifty thing that happens. A times A plus B will equal C times C plus D. Outside times the whole length equals the outside times the whole length. Right? A plus B is the whole thing. A is on the outside. So you end up with that formula. It works. Okay? Okay. And then if we have a tangent and a secant, because here's my tangent. A times A plus B still exists. But why is it C squared? Why?
Because there's only like the line only says on the outside, right?
Right.
It doesn't like go into the circle.
Okay.
So that's like I don't even know how to explain.
You're on the right track. Because C is both the outside and the whole length. Think about this, guys. If I took this CD line here, and I start to drop it to the point where it gets down to here, which looks like this picture, C becomes the whole entire length of the line, and it's also outside. So technically, it'd be C times C, which is C squared. So, 3 formulas there, plus the 2 from before, adding, subtracting. Then you should be able to answer all the questions in this lesson's problem set. Now,
I remember seeing this.
okay, guys, this inside or outside problem, inside, so you're going to do what? Plus or add. I am going to tell you, this requires a what? Formula. So what are you going to write down? A formula, the right formula, hopefully. If we do this 100 times in our homework, you will write down the formula 100 times. Now, guys, I am a firm believer that if you don't practice these things and do these things the right way in your homework, you're not going to do it that way on a test or a quiz. There's not a lot of problems in every homework section that we deal with that's like our content from a lesson. There's a lot of other things. Don't be afraid to do a couple problems in advance, like go to the next lesson, find them again. A lot of these, you know what it's called. It's called a intersecting secant and a tangent. Or this one, intersecting 2 secants. You Google search that, you will find worksheets upon worksheets with answers and without answers. Okay? You need to sometimes take charge when you don't understand something to ask questions and seek out additional problems. It's not enough to sit back and do the minimum and keep achieving something you're not happy about. Most of us probably in here possibly drive a car by now. Okay? You didn't get to the point where you got your license because you just felt like one day just doing it. Like one day, I'm going to go get my license today. No, you practiced. It took time. And if you wanted to get those licenses, you actually had to practice. No instructor or the person at the Department of Transportation wasn't going to just give you a license because you went up to him and said, I'm a nice person, let me have my license. You had to demonstrate that you practiced and you did the right thing. But because it's something you guys wanted to do, you made it happen. Guys, I am telling you, if you do some of these things, write down the formula, do a little bit of extra care to attention. You may not enjoy math, but you may be able to tolerate what I'm asking you to do. Please make it happen. So the formula is the one with addition. So what does that look like?
Arc 1 plus arc 2 equals,
Arc 1 plus arc 2 all over 2 is equal to x. Now, somebody's probably like, wait a minute. The angle in my problem, though, is not called x. It's called half of x, or 1/2 x. You got to remember that when we use formulas, sometimes our formulas coincide with the same variable in a different location or same location than what my formula does. So therefore, you have to kind of know that the x here stands for whatever's in this position. So I need to change this to a 1/2 x equals. What's arc 1?
30.
If I call that 30, arc 2 is
40.
all over 2. So we solve it. 70 over 2, so leave this alone. Okay? It's 35, okay. Times it by 2. So x is equal to 70 degrees. I don't have the degree symbols up there, but it would have to be in degrees, so 70 degrees. Questions on that? Next problem. Now we're on the outside. Is it outside or inside? Number 2.
Outside.
So therefore you're going to
You are going to
subtract. What about 3?
subtract as well.
Subtract as well. They cross on the outside. Try number 2. If you get done with 2 before we start 3, please start that one. Okay, by now we should have number 2 done. What is the formula? Arc 1. Oh, arc 1? Okay, does it really matter what I call arc 1, arc 2? Not in the large scheme, because as long as I know that it's big arc minus little arc, but we'll keep it compared to the same as what we had, right? Okay. So, x is not x anymore, it's 2x equals 75 minus
15.
all over 2. 2x equals over 2. 2x equals 30. And so x equals 15 degrees. Not too bad, right? Again, if I didn't write down the formula, then maybe, yeah, I could have some problems because I'm trying to come up with a formula and its placement at the same time. Once you have the formula, it's laid out in front of you. Just fill it in. The same formula is used for the third problem here. Guess what I'm going to do?
Same.
Write it again. Oops. I'll write it again. This time, x is equal to 20
20.
equals
80
minus
3x over
2.
And then could you separate them to like make it easy?
I could separate them, but why? Wouldn't it be better just to get rid of 2 completely?
True.
So multiply both sides by
2.
40 equals 80 minus 3x. Then what do I do?
Subtract that. Oh wait.
Minus 80? Negative 40 equals negative 3x. And then divide by negative 3. 2 negatives make a...
Positive?
Is 40 divisible by 3 by chance?
No.
So guess what? I'm going to leave it as 40 thirds or 40 over 3. It's not a nice number, but if you realize this book has not been nice numbers most of the time. Solve for D. This time, are we looking for angles?
No.
No. So now we're using the idea of lengths of secants and chords and all of those. So now we're going to multiply, right? We're going to do the outside times the, not inside, whole length. Outside, whole length. Equals outside times whole length. What's the formula?
A times A plus
B equals?
Plus.
Okay. Where A is 3, B is, C is, and D is. Whoa. See, that's where things can get a little messy, right?
Correct.
Because we're changing D to equal a B and a 3, and oh my goodness. It's all different things. But stick with the program. You're fine. So, what's the first line or first half, left side, going to look like?
3 times 3 times
3 times
3 times, I mean plus D.
equals.
3 times D plus 3.
Wow, that was kind of a messy. Okay. Each side you're going to distribute
35.
9. What? I got 3.
Plus 5.
What's the next step from here? Subtract 3D. Gone. 9 equals D squared. Square root. Don't forget
Plus or minus.
plus or minus. So the answer is 2 answers, right?
Yes.
No.
No, because you can't have like an opposite circle.
No. Can't. It's not. You can't have an opposite circle. One of these answers is not a viable choice. What is D actually finding?
The total length.
Not total length, but
All length.
length.
A length.
So negative 3, guys, is not an option because you can't have a negative 3 length. So that means D has to equal 3 and 3 only. So this problem, now we're talking about a secant and a tangent. Still the same principle. So it's not like you have to memorize 5 formulas. It really comes down to 3. Two of them you just adjust by adding or subtracting. One of them, or 2 other ones, the last 2, is just always outside times the whole thing. But sometimes it just happens to be the same thing. And then obviously the length of 2 chords, A times B equals C times D. So 3 different formulas that would be kind of needed for this. So, what's the left side going, or what's the formula again? A times A plus B equals C squared. What's A? A, okay. So it'd be A plus equals 8 squared. Distribute. A squared.
Squared plus 12A.
Guys,
12A, 8.
64. Problem. Last time, A's or the whatever verb D canceled out. This one did not. What does this one form?
Whatever we did last time.
Quadratic.
Perfect quadratic.
So that means bring everything to the same. Now, you're hoping, because A is equal to 1, yeah? Or the A of the quadratic, that you could potentially factor this. But the factors have to add up to 12. $164, will that work? 2 and 32?
No.
3? 3 and doesn't go in at all. 4.
No.
4 and 16? Oh, I think that could work.
How did that add up to 12?
But remember, 64 is negative, so Okay, guys. Let's pause. Pause for a second. The question came up is at a squared plus 12a minus 64. Instead of saying, hey, can I factor this? Can I just go straight to the quadratic formula? The answer? Yes. Could I complete the square? Yes. But sometimes that takes a lot of work to do all of that. I like to factor, especially when a is equal to 1. We found factors, but since 64 is negative, 1's positive, 1's negative, 12 is positive, so the bigger one is positive. So that means x equals, you guys should know this, 4, and x equals negative 16. Which one is not the answer? Negative 16, so the answer is 4. Have a great day.